This example is going to walk us through a relative rate of change. So we have gross domestic product for the United States between the years 2000 and 2012. So time is going to be between 0 and 12. Given to us by this function, a straight line increasing at a rate of 209.5 for every year. So that's our GDP, increasing at a constant rate. Now we're asked for, give the percentage rate of change. So anytime somebody wants a relative rate of change, you want to take your rate of change and relate it to, not f prime, that would just be 1, but the size of the function itself, right? So we're looking for the derivative divided by the function. So we'll differentiate GDP and put GDP down there in the denominator. The derivative of the GDP function is 209.5. We'll divide that by the GDP function, 209.5 t plus 11361. All right, so that function gives me the relative rate of change of GDP. So if we evaluate this function at time is equal to 0, so the year 2000, we'll take this function and plug in time is equal to 0, we get about 0.0184. So if I move the decimal twice, right, this is a kind of a, what are the units? GDP prime is measured in dollars per time per year. GDP is measured in dollars. So if I divide these, I get a rate, 1 over years. So it's kind of like a frequency. This is 1.84%. So GDP is increasing at 1.84% in the year 2000. We can do the same thing and evaluate the relative rate of change in the year 2012, and you get 0.0151 or 1.51%. So even though GDP is increasing at a constant rate of 209.5, we are slowing down at how fast we're increasing. So initially 1.84% growth in the year 2012, only 1.51% growth.